हेलो गाइस, वेलकम टू दिस चैनल। आज की इस वीडियो लेक्चर में हम मल्टीमीडिया नेटवर्किंग का प्रॉपर्टीज ऑफ ऑडियो टॉपिक पढ़ेंगे। तो आइए हम वीडियो को स्टार्ट करते हैं। प्रॉपर्टीज ऑफ ऑडियो। डिजिटल ऑडियो इंक्लूडिंग डिजिटाइज स्पीच एंड म्यूजिक हैज सिग्निफिकेंटली लोअर बैंडविड्थ रिक्वायरमेंट देन वीडियो। क्या होता है कि ऑडियो की बैंडविड्थ जो होती है वो वीडियो से कई गुना कम होती है। Digital audio, however, has its own unique properties that must be considered when designing multimedia network application. To understand these properties, let's first consider how analog video, which human and musical instruments generate, converted into digital signals. The analog audio signals is sampled at some fixed rate, for example 8,000 per sample per second. The value of each sample is arbitrary real number. Each of the sample is then rounded to one of the finite number of values. This operation is performed by quantization. The number of such infinite values called quantization values is typically a power of 2. For example, 256 quantization value. Each of the quantization value is represented by fixed number of bits. For example, if there is 256 quantization value, then each value and hence each audio sample is represented by 1 byte. The bit representation of all the samples are then concentrated together to form the digital presentation of the signal. As an example, if an analog audio signal is sampled at 8,000 samples per second and each sample is quantized and represented by 8 bits, then the result digital signal will have the rate of 64,000 bits per second. For playback through audio speakers, the digital signal can then be converted back. It is decoded to an analog signal. However, the decoded analog signal is only an approximation of the original signal and sound quality may be noticeably degrade. For example, high frequency sound may be missing in the decoded signals. By increasing the sampling rate and number of quantization value, the decoded signal can better approximate the original analog signals. Thus, as with video, there is a trade-off between the quality of decoded signal and bit rate and storage requirements of digital signals. The basic encoding techniques that we just described is called pulse code modulation. Speech encoding often use PCM with sampling rate of 8,000 samples per second and 8 bit per sample, resulting in a rate of 64 kbps. The audio and compact disc also use PCM with sampling rate of 44,100 samples per second with 16 bit per sample rate. This given rate is of 705.6 kbps for mono and 1.411 mbps for stereo. PCM encoded speech and music, however, are rarely used in internet. Instead, as with video, compression techniques are used to reduce the bitrate of stream. Human speech can be compressed to less than 10 kbps and still be intelligible. The popular compression technique for near CD quality stereo music MPEG1 layer 3, more commonly known as MP3. MP3 encoder can compress to many different rates, 128 kbps in most common encoding rate and produce high little sound degradation. The related standard advanced audio coding AACC, which has been popularized by Apple, as with video, multi, multiple versions of pre-recorded audio stream can be created, each of with different bitrate. Although the audio bitrate are generally much less than those of video, user also generally much more sensitive to Audio glitches then video glitches. Consider, for example, a video conference taking place over the internet. If from time to time the video signal is lost for fewer seconds, the video conferencing can likely proceed without too much user frustration. If, however, the audio signal is frequently lost, the user may have to terminate the session. Thank you for listening and watching my channel.